The future of food, AI-powered nutrition. Picture this. It's 7 a.m., and as you step into your kitchen, the lights adjust to match your circadian rhythm, and the scent of your perfect breakfast fills the air. You didn't choose it, your kitchen did. Last night, your wearable recorded a slightly elevated resting heart rate and reduced deep sleep. This morning, your AI assistant adjusted your meal to be higher in slow-release carbohydrates, magnesium, and certain adaptogens to stabilize your cortisol. This is the intersection of artificial intelligence and nutritional science. A shift from generic dietary guidelines toward ultra-personalized nourishment that supports your biology in real time. The foundation. Why personalized nutrition matters. Traditional nutrition guidelines, like the USDA's dietary reference intakes or the WHO's global recommendations, are averages designed to work for most people. But most doesn't mean you. Metabolic individuality means that people can eat the same banana, and one experiences a sharp glucose spike, while the other remains stable. This is influenced by genetics, insulin sensitivity, gut microbiota composition, and even the time of day. The PREDICT-1 and PREDICT-2 studies, involving thousands of participants, found that individual blood sugar and lipid responses to identical meals can vary up to fourfold between people. Genetics also plays a big role. A single nucleotide polymorphism (SNP) in the CYP1A2 gene can make you a slow or fast caffeine metabolizer, affecting heart health risk. In essence, personalized nutrition isn't a luxury. It's a scientific necessity if we want optimal health, prevention of chronic disease, and longevity. How AI sees your biology. AI thrives on complex, multidimensional data. In personalized nutrition, it draws from 5 main biological data streams. Genomics, whole genome, or targeted SNP analysis can reveal nutrient processing quirks, like a reduced ability to convert beta-carotene to vitamin A, common invariants of the BCMO1 gene. Certain gene variants in FTO and MC4 are linked to appetite regulation, which can guide AI in designing satiety-optimizing diets. Proteomics and metabolomics. Blood and urine tests measure thousands of small molecules that reflect nutritional status, like vitamin D-binding protein, inflammatory cytokines, and amino acid profiles. AI can correlate patterns here with dietary inputs to fine-tune macro and micronutrient targets. Microbiome sequencing, gut bacteria influence, calorie extraction, fiber fermentation, and neurotransmitter production. A higher ratio of firmicutes to bacteroidetes has been linked to greater energy extraction from food, something AI can adjust for in calorie calculations. Wearable and environmental data. Devices now track resting heart rate variability, HRV, sleep architecture, skin temperature, continuous glucose, and even hydration levels. AI can integrate environmental data, like pollen counts or air pollution, to recommend immune-supportive foods. Real-time biometrics, continuous glucose monitors, CGMs, allow AI to learn your personal glycemic responses. For example, you might spike on rice but not on bread, even if the glycemic index suggests otherwise. Wearable ketone monitors are emerging, allowing real-time tracking of fat metabolism efficiency. This multi-dimensional dataset is far beyond human cognitive capacity to integrate, but AI can find patterns in seconds. From data to diet AI-generated meal plans, once AI models understand your unique biology, they can predict your response to any food combination and design optimal diets. This involves macronutrient balancing. If your genetics and wearable data show you're prone to insulin resistance, AI might reduce high glycemic carbs, increase fiber, and shift your fat intake toward monounsaturated sources like olive oil. Micronutrient optimization. Your lab results might show marginal magnesium deficiency. AI can recommend leafy greens, pumpkin seeds, and dark chocolate integrated into recipes you'll actually enjoy. Chrononutrition. AI adjusts meal timing to your circadian biology. For example, if your melatonin onset is early, it will schedule the last meal at least 3 hours before bedtime to improve sleep quality and glucose control. Dynamic adaptation. If your wearable detects a sudden increase in training load, AI will upregulate protein and anti-inflammatory foods to speed muscle recovery. Already, companies like Zoe, nutrigenomics, and data are using AI for microbiome-based meal personalization, though we're just scratching the surface. Smart kitchens can scan barcodes, recognize produce with cameras, and automatically log nutrient content. Smart ovens adjust temperature and humidity to preserve heat-sensitive compounds like vitamin C and anthocyanins. 3D food printers can layer nutrients with pinpoint accuracy. Imagine a pasta infused with omega-3 fatty acids and probiotics in the exact dosage your body needs that day. Voice-controlled meal assistants will answer, "What's my optimal lunch today?" based on your morning biometrics. On a larger scale, AI will reshape institutional catering in hospitals, care homes, and schools, matching nutrition to medical needs or developmental stages. Longevity and preventive health. The emerging field of longevity nutrition overlaps perfectly with AI's predictive power. AI can calculate optimal nutrient ratios for cellular repair, balancing amino acids to support autophagy while preventing muscle loss. Long-term tracking can detect subtle biomarker changes, like creeping insulin resistance or low-grade inflammation, years before symptoms arise. AI can recommend diets rich in polyphenols from berries, green tea, turmeric, to combat oxidative stress, a major driver of aging. Nutrient cycling strategies, alternating caloric restriction with refeeding phases, can be personalized to your genetics and metabolic signals. Over time, this could lead to health span extension, more years of life lived without chronic disease. Ethical, privacy, and bias concerns. The more personal the data, the higher the stakes. Data privacy. Genomic information is essentially your biological identity. Strong encryption and transparent consent models are essential. Algorithmic bias. If AI is trained mostly on Western populations, recommendations might be less effective or even harmful for people with different ethnic, cultural, or metabolic backgrounds. Health equity. Without policy intervention, precision nutrition could become a luxury for wealthy countries and deepen global health inequality. The future must involve open-source nutrition datasets, regulatory oversight, and cross-disciplinary ethics boards. What's next? Over the next decade, we can expect real-time nutrition feedback loops, where your biometrics adjust your diet, integration with telemedicine, allowing dietitians and doctors to prescribe data-driven meals alongside medication. Agricultural alignment, where crop production is driven by nutrient demand predicted from population AI models. Edible biosensors, built into food itself, that measure and report your digestion in real time. This will blur the lines between healthcare, agriculture, and gastronomy. The human element. AI will be the most advanced nutritionist humanity has ever known. But food is not just chemistry. It's identity, culture, ritual, and pleasure. The challenge for the next generation is to merge data-driven precision with the emotional and cultural resonance of eating. The future plate will not only be optimal for your mitochondria, it will also make you smile. If you found this video interesting, imagine what's coming next. Subscribe for more science-driven insights into the future of food, health, and technology, because your next meal might just be your most personalized one yet.